Welcome to Chem Time.
Hello friends, welcome to the presentation. This presentation is about fluid mechanics, and this presentation is useful to civil engineering, mechanical engineering, chemical engineering, agricultural engineering and petroleum engineering students. I start the presentation by remembering Archimedes, whose contribution to the field of fluid statics is significant. Sir discovered formulae for calculating areas and volumes of planes and solid figures. Friends, all of you must be aware of the word eureka. I request you to mention its significance in the comment box with reference to Archimedes' principle. Coming to the fluid mechanics topic, first let us define fluid. Fluid is a substance that deforms continuously under the action of applied shear. And all of us know mechanics refer to the application of force. So fluid mechanics refer to application of force and how the fluid behaves under the influence of force. Fluid mechanics can be categorized into statics and dynamics. Statics refer to the study of fluids at rest, and dynamics refer to the study of fluids when it is moving. Fluids are liquids, gases, as well as plasma also. The properties of fluid of interest are specific weight, pressure, viscosity, surface tension, and vapor pressure. In this presentation, our focus will be more on specific weight. The concepts that are going to be discussed are difference between density and specific gravity. We also discuss the specific weight and determination of density of unknown object using Archimedes principle. Specific weight is defined as weight per unit volume, and the units of specific weight are newtons per meter cube. All of us know Newton is the unit of force. The specific weight is calculated as rho into g, where rho is the density of the fluid and g is acceleration due to gravity. Density can be calculated as mass per unit volume, and specific gravity can be connected to density by specific gravity is equal to density of the substance by density of the reference substance. In case of solids and liquids, the reference substance is water, whereas in case of gases, the reference substance is air, measured at the same conditions of temperature and pressure as that of the substance. Coming to Archimedes' principle, this principle is also known as law of buoyancy and can be used for determining the volume of the fluid, and from the data on volume and mass we can calculate the density. As per this principle, whenever an object is immersed in a fluid, the buoyancy force, which is due to the displacement of the fluid, becomes equal to the weight of displaced fluid. And the buoyancy force acts in a direction opposite to the gravitational force. And this Archimedes principle is useful to oil tanks that are placed over groundwater. Now, if the weight of an object is less than that of the displaced fluid, the object rises. If the weight of an object is more than that of the displaced fluid, the object sinks. We'll take two problems. The first problem is an iceberg of specific gravity 0.9 is floating in water whose specific gravity is 1. The percentage of volume of ice cube outside the water. This is given in JNTU K 2009 Agriculture Engineering, and this problem can be solved using Archimedes principle. First and foremost thing is the relation between specific gravity and density. Here ice is solid and water is a liquid. And for both ice and water, the reference substance is water, whose density is 1000 kgs per meter cube. So therefore, the density of iceberg is specific gravity into density of water. So 0.9 into 1000 kgs per meter cube, that is 900 kgs per meter cube. Water specific gravity is 1. Therefore, the density of water is 1 into 1000 kgs per meter cube, that is 1000 kgs per meter cube. Now, if you apply Archimedes principle to this problem, weight of ice will be equal to weight of water displaced. Volume of ice immersed will be equal to volume of water displaced as per Archimedes principle. And weight can be calculated as mass into g. G is acceleration due to gravity, and mass can be calculated as volume into density. As a result, weight becomes volume into density into g. Let the volume of iceberg that is immersed be Vi, and the volume of iceberg that outside water is V0. With the density of iceberg at 900 kgs per meter cube, weight of iceberg becomes Vi plus V0 meter cube into G 9.8 meters per second square into 900 kgs per meter cube. Weight of water displaced is similarly calculated with density of water at 1000 kgs per meter cube and volume Vi. So weight of water displaced is equal to Vi meter cube into 9.8 meters per second square into 1000 kgs per meter cube. Therefore, equating these two as per Archimedes principle, Vi plus V0 into 9.8 into 900 is equal to Vi into 9.8 into 1000. So as a result, Vi by Vi plus V0 will be equal to 0.9. That is the fraction of ice that is inside water. The fraction of ice that is outside water can be calculated as 1 minus Vi by Vi plus V0, that is 1 minus 0.9, that is 0.1. The percentage of ice that is outside water can be calculated as 0.1 into 100, that is 10%. The second problem is an object weighs 10 newtons in air and 6 newtons in water. If immersed in a liquid of relative density 1.5, what will be the weight in the liquid? The weight of object in air is 10 newtons, and we can neglect the buoyancy force of air because of its very low density. The weight of object in water is 6 newton. So therefore, the buoyancy force is calculated as buoyancy force is equal to weight of object in air minus weight of object in water, that is 10 minus 6, that is 4 newtons. The buoyancy force can be related to the volume of object displaced in water as buoyancy force is equal to volume of object into G into density of water. That is 4 newtons is equal to volume of object into 9.8 meters per second square into 1000 kg per meter cube. As a result, the volume of object becomes 4 kg per kg meter per second square by 9.8 meter per second square into 1000 kg per meter, which gives rise to 4.08 into 10 power minus 4 meter cube for the volume of the object. The object is fully immersed in a liquid of specific gravity 1.5. So volume of object will be equal to volume of fluid liquid displaced. So therefore, buoyancy force by the liquid will be equal to volume of liquid into G into density of liquid. In this case, it is 1.5 into 1000 kgs per meter cube. With this, the buoyancy force becomes equal to 4.08 into 10 power minus 4 meter cube into 9.8 meters per second square into 1500 kg per meter cube. So the buoyancy force by the liquid will be equal to 6 newtons. Buoyancy force is equal to weight of object in air minus weight of object in liquid. Therefore, weight of object in liquid is equal to weight of object in air minus buoyancy force. With a buoyancy force of the liquid is 6 newtons and weight of object in air is 10 newtons, weight of object in liquid is equal to 10 minus 6 newtons, that is 4 newtons. With this, I conclude my presentation. Thank you.
Request you to like, share, and subscribe my channel.